Alright, so number 30, it says find the inverse of the following functions from problems, and that should say 11 through 18, and prove their inverses using composition. So on number 30, we're starting with f of x, which is the square root of 5 minus x. As far as the function goes, or the inverse goes, if you just start with the whole process of switching the x and the y and then solving, then it's pretty straightforward. So we're going to solve for y. First, we're going to square both sides. So x squared equals 5 minus y. And then we're going to subtract the 5. And that equals negative y. And then to solve for y, we're going to divide by the negative. Now, if you divide by the negative, that becomes y inverse equals negative x squared plus 5. But if you left that as your final answer, you would not get the points. So what I'm going to do is I'm going to go ahead and write down f inverse equals, or f inverse of x equals negative x squared plus 5, comma. Because you have to be aware, you have to think about the fact that if you start with a square root, then your inverse is not an entire parabola, it's only half of a parabola. I graphed this earlier, I sketched it kind of earlier to think about domain. Actually, I don't even think I sketched it, I think I just set the interior greater than or equal to 0. So 5 minus x is the same thing as negative x plus 5. So negative x plus 5, which is the same thing as negative quantity x minus 5 underneath the square root. Which means we take a square root function, which normally looks like this, and then we flip it over the y-axis, so now it looks like this, and we move it to the right 5. So to the right 5, and it looks like that. Okay? So when I think about its inverse, the inverse of this, well, I've got my quadratic, so negative x squared plus 5. So if I go up 5, and then I go down with it, right? Only half of this parabola is the inverse. And so if I think about like this half versus that half, if I erase the right-hand side, then you ask yourself, is what I just drew a reflection of the square root across the diagonal? And it is definitely not. But if you erase the other side and redraw the right-hand side, you can see that it does look like that this is a reflection of the square root across the diagonal. Okay? So I know it's the right-hand side of my parabola, which I could have figured out by just figuring out domain and range. So domain and range for the original domain, negative infinity to 5, and then range is 0 to infinity. Well, the range of my original becomes the domain of my inverse, and so the domain, I don't know that one. The domain of f inverse would be 0 to infinity. So it has to exist only on the right-hand side. And that right there actually will tell me my domain restriction from 0 to infinity. So comma, x has got to be greater than or equal to 0. I didn't have to do this to figure it out. I could have just looked at the graph, but there you go. All right. Now I did say find the inverse and then prove their inverses using composition. So I did tell you that you only have to do this once. So we're only going to do it in one direction. We're going to do f of f inverse. Okay. So f is this function. So the square root of 5 minus, and then inside the set of parentheses, I'm going to put in f inverse. So negative x squared plus 5. You don't have to worry about the domain restriction when you're doing the composition. Okay? So when I distribute the negative, then I've got the square root of 5 plus x squared minus 5. 5 minus 5 is 0, so it's the square root of x squared, which is just x. And therefore they are inverses. Okay? But as far as my answer, this is the inverse. And then the composition equaling down to x is what I was looking for. Okay? Alright, so number 31. So I need to find the inverse of this rational function. Okay. First thing we're going to do is switch x and y. So x equals y minus 3 divided by 2y plus 5. The next thing we're going to do is, since we have a y in the denominator, we don't want it there, we're going to multiply by the denominator, 2y plus 5. Those two simplify each other out, so I'm left with, I'm going to go ahead and distribute my x, 2xy plus 5x equals y minus 3. So now I have individual terms, no parentheses, no multiplication, it's just, well, no distribution necessary, right? Everything is expanded out, which means I can move variables and terms around freely. So if I'm trying to solve for y, then what I want to do is I want to get all the y terms on the same side. I could subtract 2xy or I could subtract y. It doesn't really matter. If I move the 5x over here, they're both going to be negative, not a big deal. But if I move the 3 over here, that's positive and negative 2xy. Again, it doesn't matter. So I'm just going to go ahead and subtract this y over. So move this over here, but then I'm going to subtract the 5x over there. So negative 5x minus 3 or negative 3 minus 5x. Doesn't really matter. I'm still trying to solve for y, and right now I've got two different y's, or two y's, one in each term. So I'm going to factor out the y. 2x minus, I have a lot of people that wouldn't write anything here. But remember, to factor out is to divide, and y divided by y is 1. And then I'm going to divide, and that will be my answer. So y inverse equals negative 5x minus 3 over 2x minus 1, or g inverse, if you will. G inverse of x. Okay, now we're going to prove that they're inverses using composition, so I'm going to start with the original. Actually, it really doesn't matter whichever one you plug. If you can plug this into this into that one and that one, but I'm going to go ahead and plug that one into that one. So, something minus 3 over 2 times something plus 5. And that something is this fraction. Negative 5x minus 3 over 2x minus 1. And negative 5x minus 3 over 2x minus 1. Now, on the previous page, I worked it out by finding a common denominator in the numerator and denominator. And this one, I'm just going to multiply numerator and denominator of the entire fraction by the common denominator, 2x minus 1. Okay. So 2x minus 1 times all of this. The 2x, well, I'm going to talk it out, and then I'm going to do it the other way because it's kind of hard to just show this one. 2x minus 1 times all of this, the 2x minus 1 simplify out, and then 2x minus 1 times negative 3 is just negative 6x plus 3. No denominator, right? And then same thing goes here. This times this term, the 2x minus 1 simplify each other out, and then 2x minus 1 times 5 is 10x minus 5. But I'm going to go ahead and just make sure everyone is solid on the process. Okay, so 3 is technically a fraction, and you can rewrite that as 3 over 1. So I'm going to do that. And I'm going to multiply numerator and denominator by 2x minus 1 so that I have a common denominator in the numerator. This is also over 1, so I'm going to do the same thing, 2x minus 1. So the idea of having a common denominator is that you can combine the numerators, okay? So this numerator is now negative 5x minus 3 minus, I'm going to distribute my negative 3. Negative 3 times 2x is minus 6x. Negative 3 times negative 1 is positive 3. So that's all over the common denominator, 2x minus 1, which is all over, now this denominator, I'm going to distribute that, so I've got negative 10x minus 6 plus, I'm going to distribute my 5, so plus 10x, and then minus 5 over the common denominator in the denominator, 2x minus 1. Okay, I'm going to simplify my numerator, so I've got negative 5x minus 6x, that is negative 11x. The 3 simplify each other out, so negative 11x divided by 2x minus 1 over the 10x's simplify each other out, and negative 11 over 2x minus 1. So if I were to flip and multiply by the reciprocal, So 2x minus 1 over negative 11. The 2x minus 1 simplify out, the negative 11 simplify out, and I'm left with just x. And therefore they are inverses. Okay? So I got negative 5x minus 3 over 2x minus 1. You could have also gotten 5x plus 3 over 1 minus 2x. That would be the same answer, okay? Just the difference of a negative, and that's perfectly fine. All right, so my answer is the inverse, and the composition I would also be looking for. So I would be looking for this composition, and then you get down to x. Okay, so number 32. Find the inverse of each function and prove their inverses using composition. So kind of the same deal. Just to be clear, on this one right here, I did not have to find any domain issues. I mean, I could have found the domain issues, but I didn't have to because I didn't ask you to. The only reason I had to talk about domain and range here is because I had to know which side of the parabola was my inverse, and it had to be the right-hand side because of sketching and figuring that out. Okay. So number 32. Find the inverse. So first off, x equals 2 times the 5th root of x plus 4 minus 1. Ugh. Y plus 4 minus 1. We're going to add the 1. So x plus 1 equals 2 times the 5th root of y plus 4. We're going to divide by 2. Dividing by 2 is the same thing as multiplying by 1/2. So I'm going to leave it like that. 1/2 times x plus 1, although if you want to write 1/2 x minus 1/2, or plus 1/2, feel free. Equals the 5th root of y plus 4. We're going to raise both sides to the 5th power. So inside to the 5th power. We'll simplify each other out. So I'm left with 1/2 of x plus 1 all to the 5th equals y plus 4. And then I'm going to subtract the 4 over. So G inverse will equal all of that, 1/2 times the quantity x plus 1, all being raised to the 5th, minus 4. Okay? Or 1/2 x plus 1/2 to the 5th, minus 4. Alright, we're supposed to do composition to prove that they're inverses, so I'm going to take the original function, g of x, 2 times the 5th root of something plus 4 minus 1. And the thing that I'm going to substitute in is the inverse. So all of that, parentheses 1/2, parentheses x plus 1, close parentheses to the 5th, minus 4. So as far as simplification goes, I can see that the first thing to go is going to be the 4's. So then I've got 2 times the 5th root of 1/2 times the quantity x plus 1, and then all that's being raised to the 5th power, and then minus 1 in the exterior. So the next thing to go, the outermost thing acting on this expression is the 5 in the interior, and the 5 and the 5th root will cancel each other out. So the 5th root and the 5. So I've got 2 times 1/2 times x plus 1, and that's all being raised. Oh, no, just kidding. It's gone. No more 5th power. Minus 1. I'm going to multiply the 2 times 1/2, and 2 times 1/2 will simplify out. And I don't have to multiply times anything else because this set of parentheses, it just has it multiplied to this term, right? So 2 times that. So I'm left with x plus 1 minus 1, which is x. And there we go. Oh, man. Sorry. Okay, so the 4 simplified out, and that left me with just all of this raised to the 5th power. The 5th root and the 5th power simplified out. So I was just left with 2 times this interior minus 1. 2 times 1/2 is 1. And so it's just x plus 1 minus 1, which is just x. Alright, so my final answer is this function right here, and the fact that we get down to x, although I will be looking for your composition. So it's super important. You know what to plug into what. Now I did g of g inverse, and you could have done g inverse of g, doesn't really matter. I guess I can prove that. I don't have enough space. I'm gonna go over number 33. Alright, so I'm gonna start by switching the variables. X equals -7 divided by 3 times 4 minus x 4 minus pi quantity cubed plus 2. Okay, I'm going to subtract the 2 over. I'm going to multiply by negative 3 sevenths, I mean. Multiply by negative 3 sevenths. So negative 3 sevenths times the quantity x minus 2 equals 4 minus y quantity cubed. We're going to take the cubed root. So the cubed root of negative 3 sevenths times the quantity x minus 2 equals 4 minus y. We're going to subtract the 4. Cubed root of negative 3 sevenths times x minus 2 minus 4 equals a negative y, and then we're going to divide by a negative. When you divide by a negative, it will make, let's see. So when you divide by this negative, it'll make the cube root function negative, and it'll make 4 a positive. So I'm going to say f inverse of x equals negative the cubed root of negative 3 sevenths times x minus 2, and then plus 4. Okay. So let's do f of f inverse. So I'm going to start with the original function. So f of f inverse. Negative 7 over 3 times 4 minus something cubed plus 2. And that something is all of that. So we're going to subtract negative cubed root of negative 3 sevenths times x minus 2 plus 4. Okay. So I always said to really emphasize these parentheses so that you can see what you're supposed to be doing first. And the first thing you need to do is distribute this minus sign. So if you distribute the minus sign, then you're left with negative 7 over 3 times 4 plus the cubed root of negative 3 sevenths times x minus 2. And then minus, this becomes minus 4, all raised to the third plus 2. So then these 4 simplify out, and then I've got negative 7 thirds times the cubed root of negative 3 over 7 times x minus 2 quantity cubed plus 2. Well, the quantity cubed and the cubed root simplify each other out, and I'm left with negative 7 over 3 times negative 3 over 7 times x minus 2 plus 2. Negative 7 over 3 times negative 3 over 7, which is being multiplied times just the quantity x minus 2. Those simplify each other down to 1, and so I'm left with x minus 2 plus 2, which is x. Okay. So my answer is, this is the inverse. And then the fact that I got down to x, and I would expect to see the composition. Okay. And that is 30 through 33.